One of the simplest rules about derivatives is that of the constant rule. And it simply says that if you have some number, some constant number, the derivative of that constant is 0. And sort of a visual representation of this is that if you think about the derivative as that rate of change, and you have some sort of graph here, and you have some sort of constant line. If it's constant, it never changes. So if it never changes, its rate of change is 0. And this is backed up by the idea of, if we go to the limit definition of the derivative, if the function's constant, f of x and f of x plus delta x are both c, so that numerator and the difference quotient is 0. And as said in a previous video, if it's 0 in the numerator all the time, not just the limit, but it's actually 0 all the time in the numerator, then the result is 0. Unless it's 0 all the time in the denominator, then you have a whole different issue. But anyway, that's the general idea of a constant. So some examples, and again, this is really just straightforward, is that if I have the line y equals 3, then dy dx is 0. If I write it as f of x is negative 2, f prime of x is 0. If I write it as s of t, so this is a common when we're dealing with the location at time t, that's very common notation there. If I say that's 1 over pi, so it's always at the same location, well, it's not going anywhere, so its change is 0. And then if I have y equals 13k, where k is some constant, so that could be p, that could be whatever. If it's constant, then this whole number is constant, and y prime is equal to 0.